Let's move on to the second problem, Farmer John's cheese block. Farmer John has a cube-shaped block of cheese from 000 to n. It forms cube updates, each carving out a 1 by 1 by 1 cube at integer coordinates x, y, z, where x, y, z are within the range from 0 to n. Gravity does not affect the remaining cheese. After each update, output the number of ways to place a 1 by 1 by n brick in the cheese so that it does not overlap any remaining cheese. The brick can be rotated and all vertices must have integer coordinates in 0, n. The input. The first line contains n and q. The next q lines each contain x, y, z. This is a point. The output after each update prints the number of configurations for the non-brick. Now let's look at the sample input. The first line is 2 and 5. 2 means n is equals 2. And there will be totally 8 small cubes and 5 updates. The first update is 0, 0, 0, which is cube 1 in the graph. And the second is 1, 1, 1, which is cube 8 in the graph. These two cubes are far from each other, so they cannot form the space for the non-brick. So the output for these two lines are zeros. The third update is 0, 1, 0. 0, 1, 0, actually, it is cube 3. So we know cube 1 and cube 3 are adjacent to each other, so they can form the space for a long brick. So the configuration becomes 1 now. And then the next is 1, 0, 1, 0, 0. 1, 0, 0, which means cube 2. So cube 2 and cube 1 can form maybe another space for the non-brick. So the configuration becomes 2. The last update is 1, 1, 0. This is cube 4 under cube 8. So now cube 4 and cube 8 can form maybe another configuration. And cube 2 and cube 4, cube 3 and cube 4 can form maybe 2 more configurations. So totally the output will be 5. The brick is a 1 by 1 by n non-brick that can be placed along the x, y, or z axis. So there are 3 possible orientations. If the brick is placed along the x-axis, it requires the square cells on the yz plane. The square cell yz, y plus 1, z, y, z plus 1, and the last point, y plus 1, z plus 1. And all n small cubes along the x-axis must be completely empty. Similarly, the same logic applies for placement along the y-axis and the z-axis. So for a brick along the x-axis, we fix y, z, and all positions from x equals 0 to x equals n minus 1 must be empty. For a brick along the y-axis, we fix x, z, and all positions from y equals 0 to y equals n minus 1 must be empty. For a brick along the z-axis, we fix x, y, and all positions from z equals 0 to z equals n minus 1 must be empty. Thus, the number of possible placements along the x-axis equals count of all y-z pairs, where the x-axis is fully empty. Similarly, for for the other two directions. This problem is essentially about counting using hash arrays, not dynamic programming. The idea is somewhat like 3D prefix counting, but the actual implementation uses a 3D array simulation. Now let's look at the code. The most important part is the definition of the three-dimensional array, int. You can read the code. Vector, 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 int, int. 3, vector, vector, int. N, vector, int, n, n. This to define a three-dimensional array. The first dimensional is with 3 elements. Actually, there will be 3 n by n two-dimensional arrays. Int 0, y, z represents, in the x direction, how many cubes are left above the small cells y, z, y plus 1, z, y, z plus 1, y plus 1, z plus 1. Initially, each cell has n cubes. Int 1, x, z represents, in the y direction, how many cubes are left above the small cells x, z, x plus 1, z, x, z plus 1, x plus 1, z plus 1. Int 2, x, y represents, in the z direction, how many cubes are left above the small cells x, y, x plus 1, y, x, y plus 1, x plus 1, y plus 1. Each time a small cube at position x, y, z is removed, all three directions, x, y, and z, lose 1 cube. In x direction, 1 cube is removed from each of the cells y, z, y plus 1, z, y, z plus 1, y plus 1, z plus 1. In y direction, 1 cube is removed from each of the cells x plus z, x, z, x plus 1, z, x, z plus 1, x plus 1, z plus 1. In the z direction, 1 cube is removed from each of the cells x, y, x plus 1, y, x, y plus 1, x plus 1, y plus 1. If the number of the cubes above a cell becomes 0, it means this cell is empty and a long brick can be placed. So we increment the answer n plus plus. The time complexity for the solution is each removal of a cube updates 3 directions in O1 operations. The total complexity is OQ, which satisfies Q less than or equal to 2 times 10 to the power of 5.